welcome to seminar, everyone. We have a small group here in the room, but welcome to those of you who are virtually connected too. So today we have a seminar by Dr. Nancy Boury. I think most of you know her. She has been an assistant professor in the Department of Pathology and Microbiology since 2016. And but she's been at Iowa State for many more years before that. She was a senior lecturer in primarily microbiology. But as an assistant professor, she has a 80% teaching appointment, and she teaches courses in microbiology and genetics. And she also has a 20% teaching research appointment in the scholarship of teaching and learning. And so Nancy today will be talking about several aspects of her program here in the department. And also a very important announcement is that Nancy just recently won an award. It's called the Karski Awards, and it's a very prestigious, very competitive national award granted by the American Society of Microbiology for excellence in teaching in microbiology. So congratulations, Nancy. So with that, I will hand it to Nancy.
Fantastic. Okay, now that I'm good and embarrassed, so the title of the talk today is Evidence-Based Best Practices in Course Design, Student Engagement, and Assessment of Student Learning. And this is actually, Justin and Leonore came up with it because I was slacking in my title choosing. I was actually dithering a bit. So hi, I'm Nancy Boury. Just from a background perspective, my undergraduate degrees are from Wartburg, and I have a bachelor's in biology and chemistry. My master's degree is in medical microbiology and immunology, which is really a lot of my science research was in immunology. And then my PhD was from Iowa State University in molecular cellular developmental biology. And the courses that I'm teaching now, because all of that happened a long time ago, are 80% teaching. So in the fall, I teach General Bio 211. I teach the Microbial World, which is Micro 101. I have taught in the past the Phage Discovery Lab. This is the first year I'm not teaching it. And then 265, Micro 265X, which is predicting the next pandemic, living in a one health world. And I started that one fall 19, not after the pandemic, but before. Wow. So the next class I build is going to have to be how to win the lottery. So spring classes are General Micro 302, both the online and face-to-face, which are two very different, same learning goals, same learning objectives, very different learning activities. And then Micro 450, which I just handed off because I'm teaching 265 again. And then in the summer, I teach, or have taught since 2015, the genetics 313 and general micro 302. And the summer 2020, I taught a digital internship to fill the gap of students that didn't have internships because of the pandemic. I built a digital internship. So that's kind of my teaching. So what this looks like, you can kind of see this in really small areas here, is this is looking at it from a student credit hour perspective. I typically generate, looking over here, student credit hours per faculty FTE. So that's taking into account the 80% appointment. I'm generating between 700 and 1,200 during the regular year, and 200-ish, between 2 and 250 in the summer, student credit hours per FTE. The average for faculty in PALS tends to run in the 280 to 320 range. So if we look at like full more than average, so number of times more than average, I'm usually somewhere between 2.5 and 4 times the normal teaching load. Part of the reason for this is I teach a lot of classes. The other part of the reason for this is I teach a lot of large classes, which for a research perspective, if you're working on the scholarship of teaching and learning or discipline-based education research, the large class sizes are really good. But it does mean that there's a lot of class time and there's a lot going on. So how do we generate evidence about teaching and student learning? There's two complementary disciplines that work well together, but they are distinct: the scholarship of teaching and learning and discipline-based education research. And you will hear some people use them interchangeably. You will hear some people not use them interchangeably and very vehemently not use them interchangeably. Well, there are some similarities. Hey, what's happening now? It's just killing me. Can I forward?
You guys figure.
Okay, are we? The next slide.
This is exactly what was happening.
Okay, so let's hope that it's going to behave itself. We're going to let it go, and we'll see. Okay, so scholarship of teaching and learning is oftentimes course-based innovations, like how to teach differently, how to teach better, how to do activities that are evidence-based and potentially evidence-generating. What we're trying to demonstrate in social work is the utility of this new thing we've created. This tends to be smaller studies, and it usually within your classroom or maybe a few partners. Questions or research hypotheses like, do micro students achieve intended learning outcomes with game-based learning? Because we'll talk about game-based learning. In discipline-based education research, it's more the education research and it's more generalizable hypotheses that are being tested and generalizable conclusions that are being achieved. These tend to be larger studies, usually multi-university studies, and they have kind of larger hypotheses and larger research questions, like do the misconceptions about mutations in genetics persist throughout an undergraduate student's career? So which of these misconceptions are durable, meaning they persist throughout, and which are transient, so the ones that are being resolved? Both Sodal and Boury, though, will have disseminated research or disseminated work where you're going to disseminate your new teaching tool to a wider audience. And that could be at meetings, it could be in papers, it could be in posters. They're both going to use student data. They're both focused on education, and they're both evidence-based. We don't do either Sodal or Boury in a vacuum, and they're both evidence-generated. So you move forward and add to the body of scholarship with both of these. So looking at the given title of the talk, we're going to look at kind of the learning cycle. And the first thing you do when you're teaching is figure out what it is you're going to teach. You define the learning outcomes. And a lot of times in microbiology, we have ASM to look to for their guidance. In genetics, they have the Genetic Society of America, or GSA, has a framework. APS is working towards that with stakeholder publications, looking at what employers are looking for. And then the land grant mission is also another source for this, that we're creating and sharing knowledge. And then providing learning opportunities. This is where Sodal comes into the picture. Building new case studies, doing game-based learning activities, building podcasts and podcast annotation, digital internship opportunities, doing a journal club with the students. That's what Micro 450 is about. And then assessment, this is in my research program, that's the Boury side of things, where we're building concept inventories. And I was part of the microbiology concept inventory team that was in 2016. And I'm currently doing a genetics concept inventory group, and we're currently doing a RCR or research concept inventory that we're also have worked in the process. Okay, and then redesign your learning opportunities based on assessment data. And so this redesign, every class that I teach, I reassess every year and either add to it or subtract from it based on my intended learning outcomes and the assessment data from those intended learning outcomes. In the process, in the last few years, since 2016, I created a course, Micro 265, the pandemics class, and Micro 490B, where I built a digital internship. So that's kind of out of this learning cycle in that it hasn't been reassessed or redesigned because both of those courses are really new. So if we want to look at what this looks like in action, the course goal, this is my Micro 101 class, where I'm listing out the course goals, the learning objectives, and then showing the students where the assessment is going to happen for this. And this is actually part of my syllabus in this class, showing both formative assessments where you get a lot of feedback for students, and summative assessments where we see whether or not they achieve the learning outcomes. And being able to align it like this really makes sure that there's not a lot of mystery to the class as the students are coming in. It also makes assessment really pretty straightforward because you have everything aligned. And with all of this kerfuffle with the tech and everything, I forgot to mention, if anybody has any questions, either face-to-face or from WebEx, feel free to ask, and I'm good at this. So student engagement, we've spent a lot of time, both my presentation and Leslie's presentation, talking about learning outcomes and learning objectives. So I'm going to kind of leave that one be. I'm going to start with engagement. And one of the focuses I have is student literacy. So working with the English department, building a STEM-based microbiology and genetics-based English 150 and 250 classes. Our learning community students never fill an entire English section, so we typically share with another STEM discipline like genetics. And we build a course where they have to fulfill the learning objectives of English, which are the written, oral, visual communication objectives, but we use microbiology examples for this. So they read the book, The Doctor's Plague, about Semmelweis and telling people to wash their hands between the morgue and telling people to wash their hands between the morgue and the maternity ward. And he dropped the mortality rate because there were a lot of people dying before he said, you know, maybe washing your hands is a good idea. And he dropped the mortality rate, and to thank him, they fired him. And so it makes a really good story. It's a true story, but it also makes a really good example of why communication is important. Because part of the reason Semmelweis had such a poor ending is his communication skills were not the best. And so it fulfills a lot of the English requirements. It also fulfills a lot of our interest in microbiology. So we built that course and taught it for several years. There's another project that a colleague of mine from UC Irvine, who is now in the Netherlands, but she was at UC Irvine at the time, met at an ASM meeting and put together a project where we break down primary papers into just figures, like an individual experiment per figure, and use this. I was using it in Micro 302 and Micro 450. She was using it in her microbial genetics class, and using this to teach students about how to read primary literature and break it down into smaller pieces. Then the other piece of scientific literacy I want to spend a little more time with, because it's the newer one, is this digital internship, where students annotated This Week in Microbiology podcast, listening to the TWIM podcast and listening for techniques that they had learned in their microbiology curriculum. These are juniors and seniors, so they would have had lots of lab experiences. Listening for techniques, listening for concepts, because their goal was to mark out these TWIM episodes for use for general micro instructors. And so it benefits general micro instructors who want to increase scientific literacy by students because they are working through this process. Okay, so When asked what does the scientist do, thoughtfully holding up test tubes for no apparent reason since 1846, right? If you say, what do scientists do? Well, this isn't it. Okay, read, write, present primary literature. And this is an article in Science from 2016, I believe, how to seriously read a scientific paper, because it is an important skill to have. And so one of the reasons we did This Week in Microbiology is this is a podcast that is a journal club where these very intelligent individuals get together and talk about current papers that are interesting in microbiology. And the discussion panel rotates between different scientists. We get to hear how scientists talk with each other. And the topics tend to be very current, and they're based on peer-reviewed scientific literature. So the students get an impression of what it means to be a scientist in a scholarly sense that's somewhat out of what we would see in a regular classroom. And when we did this data set, this is results from the paper that was published about this. When we did this, one of the goals of this podcast annotation project was to fulfill a lot of the goals of the microbiology internship. And that we look to ASM for their skills or competencies. And one of the things ASM wants us to do is be able to formulate hypotheses, analyze, interpret results, use mathematical skills, effectively communicate fundamental concepts of micro, and identify credible scientific sources, and identify ethical issues, and collaborate. So these were the goals set out by the American Society for Microbiology. We gave a Likert scale asking students how much they thought that this internship increased those skills. And you'll notice there are 3 of these where all 7 students, because this was an internship, there was only 7 students, all 7 students said a great deal. Like it was a 5-point Likert scale, and they gave 5s to analyze, interpret results, effectively communicate, and collaborate with each other, working towards a common goal. To me, one of the really most interesting things about this is that these students that were the interns were kind of the alpha students that typically don't work and play well with others, because they're the ones that when you assign them group work, go do it themselves, and I'll do it and whatever. They all 7 thought that it was really exciting to be able to work in a group, and that their group mates were all on task. So I think I unspoiled group work for them, at least to a small degree. So to me, that was a great idea. And then just some high points here, that they liked that everybody was contributing, that they loved being able to look at the graphs while they were listening to the podcast hosts talk about these graphs, and because it made it just a little bit more real for them. So that's that project. So that's a great project for seniors, because it really doesn't fit well if you don't have some of that background. What about the first year students? How can we get scientific literacy and the skills to evaluate sources for the first year students? Well, I do teach first year students. I teach general micro, I teach general bio. And as an honors segment of my general bio class, I have worked with the Wikipedia education folks and set up a course for the students to become Wikipedia editors, going through training where they learn how Wikipedia works, how to cite Wikipedia, or how to cite in Wikipedia, how to edit in Wikipedia, what the neutral voice means, what a good source is, what a bad source is. And so, I started out small in fall 18 with 7 students, and they did a conceptual paper on despeciation, like an article on despeciation, and a article telling you everything you ever wanted to know about this starfish. And then fall 19, this is a pitcher plant mosquito. Those non-entomology folks, this is the pitcher plant mosquito that the students thought were interesting. And then fall 20, this was all done virtually. respiratory pigments, a Chinese rice fish, and radiotrophic fungus, which I thought was really interesting. These are the fungi that eat radiation. And then the average hits per day, the students will email me going, did you see the average hits per day? Is like 200 for the radiotrophic fungus one. And it kind of varies with, you know, how popular the topic is. But students, I mean, they added references, they added paragraphs, and the info that they added, most of this info stayed, at least until because I checked it like 2-3 months ago, and all of their edits were withheld, which means another editor didn't come through and erase it. And particularly for the student projects, they do have a fairly tight oversight as to how this goes. And so I was pretty excited that my students did it well enough that they didn't get their changes erased. There was a couple of formatting issues, but other than that, pretty good. If anybody wants to do a Wikipedia editing project in one of their classes, please let me know, because I know a couple of the people you could set this up with. Okay, so engagement. One of the things I kind of want to keep in mind here, that traditional lecture is about 800 years old. This is something that arose in a time where books were a thing, but they were really scarce. So lecture is state of the art circa 1300. Right? So this is what it would look like, a person reading from the pulpit or from the lecture, and everybody scribbling it down. So it's like the first mass copy. Fast forward several hundred years, it doesn't look a whole lot different. And you might say, oh, that was the 1920s. Fast forward again. Okay. So lecture does have a place, but it doesn't work as well to teach students. We have other ways to teach and engage students better and get better outcomes than we would in this kind of format. Okay, so what can you do with 250 plus students? I mean, if you're given 10, 12 students, it's pretty easy to do something engaging. How can you engage with 200 plus? Well, one active engagement option is game-based learning. Game-based learning uses game psychology, like what makes a game fun, what makes people come back to games, what makes games motivating, to increase student motivation and then achievement, really. Okay. This is a significant overlap with the high impact practices that discipline-based education researchers have identified. Things like giving student feedback, constant, regular student feedback, and other high impact practices. Successful games have this idea of fun failure, where you have lots of low stakes opportunities. This is what we would call in education a lots of formative assessment, okay, with that feedback. Narrative or challenge, in game terms, you can have things like tower defense, you have to defend against all others, or some sort of a completion journey or something like that. You also have community building, where you're engaging with your fellow students, you're also engaging with the material. You could also engage as a competitor, or you can engage as a collaborator. And so that particular perspective as well. So I'm a big fan of game-based learning, and this comes in various shapes and sizes. In 2017, I did a Miller Grant project. The students would follow Labby. Labby was a newbie intern microbiologist that had been sent with his group to an asteroid. And the asteroid, or the ship crashed on the asteroid, and then they had to go out and find supplies. And while they were going out and finding supplies on these little stations, each of the stations gave them challenges to get to the next station. And they were suspiciously like, what's the structure function of a microbe? What's the genetics of a microbe? What's the metabolism of a microbe? And so each of these areas were just the units that you would normally have for microbes. So to exit the station, they need to take an exam. 2 of the 4 stations blew up as they left because that was just part of the story. They actually had to dodge type 6 secretion systems, so they remembered that there are removed things. So the student learning and motivation data, we've gathered some of that, but we need to analyze it more deeply. We have some initial data, but again, COVID delays, we don't have that one done yet. This actually employed a graduate student to do the writing, and we had a undergraduate artist in BPMI. And so this is our crashed spaceship. Here is our intentionally generic Laddie. We don't know anything about Laddie because that's the student. And here's our two, the postdoc and the graduate student, and we had to have a space turtle because why not? And you know, they even put me in there, so I'm there, and they're gonna have to save me because I'm in the crash ship. And I think the author, if I remember correctly, had me break my leg, so I can't go there. So I couldn't go with it. All right, and so this was the project. Is data from this actually showed that face-to-face and the online sections had normalized learning gains in about the 20% range. And we need to go, this is just the first year it was taught. There's a second year, we need to combine the data because I would like the benchmark for an interactive learning environment is a normalized learning gain of 30% or better. And we're getting there, but we weren't quite there yet. But yeah, that's the narrative driven. You can also do games that are just fun and easy because honestly, the Miller Grant project, that was very time consuming to put together. You can also just use a Jeopardy template and do your reviews as Jeopardy. So students are competitive with each other. The other project that I've spent a lot of time on in the last couple of years is playing word games to teach vocabulary. Why do, it seems like vocabulary is the base model of everything. Why should we care about vocab? Well, STEM disciplines have a ton of jargon. The average Spanish or French vocabulary recommendations from the world language and cultures, like the people that teach foreign languages, would like to see students learn about 1,400 new terms per year. An introductory biology textbook has 18, almost 1,900 terms per year. Physics has 15, and chemistry comes in at a whopping 2,900. I think they're kind of cheating there because I think each chemical gets its own name, and that's why they have all those terms, but I'm not sure. So one, there is a lot of jargon that they need to learn. Two, knowing the language of a discipline actually shapes how you think. So the quote is, thoughts require language and language requires thoughts. And so if we focus on the language, it will actually refine some of the thought processes students are having as well. And then the last part here is the observation that students that come into classes with a stronger vocabulary tend to read more, get more out of their reading than students with a weaker vocabulary. So it's the rich get richer and the poor get poorer. The gap between the strong vocabulary students and the not strong vocabulary students really does widen if you don't do anything to intervene. And so that's what this is intervening. Okay, so there's kind of a continuum of vocabulary building. There's this, the memory or familiarity on a Bloom scale. Leslie was talking about Bloom's. This is the knowledge. And so you can do things like build them a Quizlet. You can do a crossword puzzle. You could do this as Quizlet Live. You could do it as homework. You could do it in class. Okay. The understanding and comprehension, again, one step up on Bloom's taxonomy. Have to do 6-word definitions or haikus. We'll look at what 6-word definitions look like. And the last thing, which is more of a comprehension application, so we're again getting more complicated on Bloom's, plain word games where you have to know the connotation of words, not just the denotation. Things like just one and code names, and we're going to show you an example here in a second. You can do games live and in class for students. I just did just one yesterday in biology 2. And I haven't asked them to vote yet. I wanted them to think about it. But the response in general was really pretty good. We'll look at what that looks like here in a second. So it's important to note though, if you say I'm going to do a Quizlet, have the students do a Quizlet, do not have them make their own Quizlets. Because if I said gram-negative, a Quizlet's, or a student's Quizlet would say gram-negative is pink. Okay. They're not wrong, but how useful is pink when you have to really understand what a gram-negative cell is? So my faculty definition, bacteria that have a thin layer of peptidoglycan, 2-cell membranes, LPS, stain pink on the gram stain, and I throw a picture of the gram-negative envelope in their little Quizlet flash card, so that they get that impression of what this really is. Okay, and I shared, if anybody wants to, you can see my general micro. I've got general micro, general bio, micro 101, and general genetics Quizlets where I have built all of their terms. You can switch from Quizlet to a crossword puzzle. This works really well for homework. And there's programs where you can, I use Crossword Weaver. These programs, you basically just give them a list of terms, and it will make by hand automatically make a crossword puzzle like this. So I literally did just download my term list from Quizlet and then transferred it over to the crossword puzzle. So creative games, this is an apocryphal story that Ernest Hemingway was once told or once challenged, like a bar bet, to have the shortest story in the English language that has all the elements of a story. And the shortest one he had was 6 words: for sale, baby shoes, never worn. 6 words. So what I do is ask students to pick 10 words from their vocabulary list, define them in their own words, but only 6 words. And they need to be detailed enough to be exclusive to their own term. So chloroplast, eating cyanobacteria, hidden prokaryote, eukaryote, photosynthesis. That was actually one that a student did for what a chloroplast is. So we are short on time, but what do you guys think? Define a jargony term in 6 words.
But nobody knows it.
What? Well, it's just any kind of term that is to your discipline.
Oh, I thought you define jargon word.
No,
A jargon word.
any word. Like, well, like pick a jargony word.
Canadian.
Canidia. Okay, so how would you define canidia in 6 words, and only 6 words, or exactly 6 words? That's a good one, by the way. We're just doing fungus tomorrow in 211.
Asexual fungal spore.
Asexual fungal spore. Haploid. I got 4 for you. Non-diverse.
No. Dissemination, comma. Multiplication.
Yeah. So, as Mark's demonstrating, this is not easy to do. Okay, and so students can do this. I mean, it's great for them to kind of put the connections together. So say it in 6 is a good exercise for them. And from a Bloom's level, that's a create kind of thing. Okay, so in Micro 101, I showed the video World Without Microbes by Ed Young, and it's basically death and mayhem if microbes don't exist, and cannibalism is mentioned. It's great. But then here's a lot of the vocab that's just in this 5-6 minute video. And so if there's a game called, this one isn't just the code names, where you are the red team or the blue team, and you are supposed to have your teammates pick the words you're supposed to pick. They don't know which words they are. But your team's words, so only the red ones or only the blue ones, and nobody can pick the black one. And in this case, it's mitochondria. So word if you say to connect two or more of your terms, if you're blue or if you're red, that doesn't get the other groups and doesn't get the assassin word, which ends the game for you, right? Again, this is a really creative way for students to connect their terminology. Right? And so that's
Has to be connected physically or by meaning.
by meaning. You can't, if physically, that's cheating in this game. You can't be like the northwest corner one. Oh, and you can only use one word to do it. So with one word, connect, I could see it, anoxic and anaerobic. You could say air and hope that they don't pick anything else that might be in there, like oxygen, because if they pick something else, then their turn's over. Right? But again, this one's actually kind of challenging too, but it's getting students familiar with their vocab and have it in a fun way. Okay, so normally this is about 5-10 minutes of class time, and we would then debrief at the end of this saying who got the most connections, what word did you use, and why, and did your teammates get it, did they not get it? And a lot of times the learning happens both when they're struggling with it, but also when you debrief and say, what is it, what did all of these groups have in common? What do these terms have in common? And how should you connect it with what you already know? Because that's where the learning happens. All right, and then just one is cooperative, and this is an actual just one part, and it's generic words. So the person that's it has, shuts their eyes and says, pick word number 3 or word number 2 or word number whatever. And the rest of the group gets to give a single word clue to get that person that's it to say their word. And if they do, the whole team gets a point.
This is Trivial Pursuit.
No, not really.
Similar.
It's more word games. But yes, so like if you have Spielberg there, yeah, then it is Trivial Pursuit, because then you have to figure out what movies,
Non-trivial.
Okay, so if they guess wrong, no point, no point, or no card or whatever. If there's any, this is the trick to it though. If there's any duplicates in the clues, so you're going to get potentially in a group of 6, you'll get 5 clues. But if everybody says the same word, those words get eliminated. So you have to say words that are similar and going to trigger this response, but not so close that everybody will say the same thing. So like if I had to tell somebody, if I want somebody to pick the word tattoo, they're going to have, if you say ink and somebody else says ink, now they don't have that clue. So it gets students thinking creatively. And so this was one that I used in Micro 101, bacteria, anaerobic, peptidoglycan, and prime. And the other thing is the person that's it doesn't see the card, so they don't know what these words, they could be anything. So. Word games in general, the idea of word games is to encourage these creative definitions and building connections to other material, because again, that's where learning happens. The connotations of the words, not just the memorizing, and retrieval practice for both clue givers and the receivers of these clues. They're actually having to reignite or reconnect with some of this work that they have been doing. So debriefing often reveals the common problems across the whole class. We identify which clues were eliminated and which were used most frequently. Code names, what were the most words that we could connect? So how this helps students? We know that students often overestimate their knowledge of jargon, particularly if the words that are jargony words overlap with English. You ask a student if they know what the word theory means, they will probably say yes. And then you ask them to actually define it, and it will probably be not the right definition. Right? Memory is ineffective, it's cumbersome, it's boring, students will not do it willingly. Learning vocabulary in context is going to give you the greater conceptual understanding, particularly in the sciences. And then the other piece to this is excessive jargon and vocabulary is barrier to STEM persistence, particularly in underrepresented groups. So first generation students, students in marginalized groups. So this is actually a diversity piece as well. All right, so why do we use these multiple modes of engagement and assessment? Because we were wanting to be an inclusive classroom. Students come to your class with lots of different abilities, both strengths and weaknesses. By varying your engagement techniques, by varying your assessment techniques, you give more students the opportunity to demonstrate what they know and have. If all you're doing is teaching them to do a multiple choice test, or if all you do is use multiple choice, are you teaching them material, or are you teaching them the content, so to speak, or are you teaching them how to do a multiple choice test? So there is that problem as well. Okay, if all you do is lecture, how do you build those connections for the students? So we need to have the students actively engaged. So the cartoon here is for fair selection. Everybody has to take the same exam. Everybody climbs the tree. And obviously the fish is going to have some difficulties. The whole idea of this is we want to clear the path for people with special needs because we want to clear the path for everybody. And inaccessible design excludes some people. Accommodations are going to make this accessible by changing the situation. But if you have accessible design to start, you don't have to make accommodations. So when you're talking about course design, don't design with accommodation in mind, design with accessibility in mind. We want it to be accessible for all. Okay, so I have 3 minutes for research. I could talk about research, but I could also do Q&A, and I want to be respectful of everybody's time. You guys want to do research? Yay, nay, questions?
Is it okay to ask questions?
It is perfectly fine to ask questions. Please do.
So I'm sure that you've gotten some quantitative feedback from students on the effectiveness of your sort of game-based learning.
Mm-hmm.
And I'm sure there's many other classrooms that have it. What kind of pushback do you get?
Oh, you do get pushback, particularly if students are very serious about their studies and they think that it's silly. And so what often happens is, like, the first couple times you do some of these activities, what I will do is I will gather the data and show the next class like where the learning gains are to demonstrate it's effective. Because that is the pushback you get is students thinking that it's silly. At least that's a pushback I've got. And usually we get over that by the end of the term, usually, not always. So, yes.
For the sake of the audience, who maybe not doesn't know about your research, could you give us like the elevator speech about what is your research?
Okay.
What do you do?
Research-wise, I have 2 different things. The game-based learning stuff is part of it, but the elevator speech is on concept inventories. And I've been building concept inventories since 2016, where you develop the learning objectives, you develop open-ended questions, you get written responses in the interviews, you change them to multiple choice, and then you do a whole bunch of psychometric testing. The other thing that concept inventories, why we do concept inventories, is because it gives a standardized measurement in a multiple choice format that is easily accessible to faculty to measure learning gains, particularly if you have a standard set of learning objectives. So the first concept inventory I was working on was the microbiology concept inventory, and that's based on the 27 fundamental statements that ASM said this is what they need to learn. And so we have, from the national level, what they need to learn, and then we built that around those. For mutations, we were looking at the GSA, or Genetic Society of America, what they need to learn about mutations, and built that as well. We have 5 in the works right now for genetics. Mutations and pedigree analysis are getting written up as papers. Epistasis epigenetics we're doing the data analysis. And Hardy-Weinberg equilibrium, we're still gathering data. The last set is this semester. So that's is what I've been spending a fair amount of time on from a research perspective. And
Can you go a little more detail there on the concept inventory?
yeah,
So, I don't know if we can go back, could you just give an example with, I guess it's the microbiology one, but.
yeah. So for I'm sorry I did the genetics one because that's the one that I'm writing right now.
So they, in micro, they list an inventory or a goal.
Right,
So the learning objective is just kind of restating that from another angle, right?
right. Well, for the MCI, yes, that's basically what they did. And
And then what do you do to make it an inventory?
so for the MCI, what they did was do true or false statements that were targeted towards those statements.
That
So-
are substantive, like they're standing, like.
So if the statement in microbiology is, about evolution of metabolic pathways, and you make a true false statement that says the shared metabolic pathways in these two species are evidence of previous ancestry, and it's true or false. And then the important thing is explain, because when the students explain their true or false answer, you get a whole bunch of wrong answers. Very similar to this one, this is mutation. So the learning objective was to define mutation. If you say, one of the questions was, if it was true, is this a mutation? If a ribosome slips and it puts an extra amino acid in the protein, is that a mutation? And about 60% of the students said, yes, that's a mutation. That's incorrect. And then you go, well, why? Because then they'd say, mutations any change, this is the coded response. But the actual response was, even when it's not directly affecting this genetic code, it's not heritable, and it could cause deviation from the code that would have been, thus mutates the message. So they're using mutation in a common English term, but they aren't defining mutation as a heritable change. And so they're missing what that means. Some of these, overexpression of a gene could have a drastic outcome. Overexpression of a gene can lead to a mutation. So they have cause-effect reasoning problems. So that particular defined mutation question was, you have a change in the promoter that causes overexpression, and they said, yes, that's a mutation. And that's true because it's a change in the promoter, but then their explanation was the overexpression could cause a mutation. And I'm like, no, that's not right. And so we're trying to identify where students, and a substantial number, because we're talking 400 or 500 data points here. So
Is
where
it
they're
a
making their mistakes.
misconception inventory?
What?
Is it more of a misconception inventory?
It's both. It's
Where do you go wrong?
yeah, where are you going wrong? So the advantage of a concept inventory are a couple-fold. One is we've got a standardized thing that everybody can use, so we can compare apples to apples. So we're measuring in feet instead of literal feet, basically. So that's measurement is good. Any scientific discipline needs measurement. But the other thing is, if you do this as a pretest, you know where the students are going wrong, and you can see where their mistakes are being made, so you can target and directly address those mistakes. And so that's always a good thing. And so that's part of what this is. I think I'm already over, but I'm happy to stay in chat. But this was one NSF grant, and I don't have my end of thing. We'll go through. We actually will go through. This is actually congruence testing. We created a new method to do the last validation. So instead of making just statistical inference, we're directly measuring whether we're capturing students' thinking, because we're recoding using the original code book, the last round, and then we use the statistical stuff. I should actually leave it here. What we can see here is when they got wrong answers, most of the wrong answers they got are for the reasons that we think they're going to get them wrong, because their explanation matched with what we had thought, with what we designed that distractor for. But occasionally you can see they're guessing, they get the right answer, but their answer is wrong. Like their reasoning is wrong. And then this is just, why do we do this? And Okay, current projects, concept inventories, I've got 2 MSF grants. This one I'm the PI for, this one I'm a co-PI with, where we're doing genetics and then RCR training. And then I also have a side project where I'm mentoring faculty on RCR training within their cures or course-based undergraduate research. And the last thing, engagement projects, I'm currently working with Rogers Grant on powdery mildew and barley, doing the specific aim 3, which is the outreach component or the education component. And we just submitted a paper last week on potato late blight and southern forest leaf blight as an opportunity to discuss diversity and disease resistance. So, and then the last thing I did actually want to plug is the PALM project. The PALM network is a network of faculty trying to encourage and increase active learning opportunities for students by putting up a mentoring network. I'm a PALM mentor. PALM will pay for travel to education meetings. They will pay for publication fees. I'm happy to mentor a couple more faculty, and sometimes they have faculty across the country that mentor each other, but a lot of the mentor-mentee pairs are in the same university. So I'm, the October 30th deadline is fastly approaching, but I'd be happy to do it for January. So anyway, I think that's it, and I think we're good.
Always managed to get very, very good jobs.
All right, well, thank you, Nancy, for your
I just
talk.
feel like I feel like I've gone way over.
Well, we have problems with that.
Oh, no.
All right. But anybody need anything?
I don't see any questions in the chat.
Inspirational.
Yes,
I don't know about
thank
that.
you.
But, and then have the thank you messages. It's not forwarding again.